65 baguettes. Baguette would be my choice. Yeah, 65. I mean, you can go up to 70. The problem is, as soon as you go 70, you start to lose definition on a baguette, but you get a more beautiful interior structure. We can maybe put these just over to the sink real quick. That'd be great, just so we can clean up here real quick. So nutritionally speaking, if I were to make bread with that, I would get something that still has a slight gray tint to the crumb structure, but would perform very different than the whole wheat bread right now. This is awesome. Next thing we're going to look at is salt real quick, okay? And hopefully by the end of the lesson, I get a little better understanding of it. It's just a little sluggish, but hopefully we'll sort of accelerate that experiment, because last time I did it, it blew up in 20 minutes, and now it's just obviously, and it's chilly in here, but I can set it into a warm.
Hold it in their hands.
How much time do I have?
6 minutes.
No, let's do this. Let's fill these. We should be fill the hot water real quick. We're just gonna accelerate something. Yeah, I'll do this one. We're sticking 2 of these.
Not the cold water one?
We're going to have to. Well, I mean, we have to do, if we're going to do a control factor, we have to do all of it.
That's true.
Does that make sense? Okay, so, holy Jesus, this is awesome. Great. So when we're looking at salt, guys, you all know what it tastes like, right?
Yes.
Are there different kinds of salt?
Yes.
Give me an example of some salts that you're familiar with.
Kosher.
Kosher. Sea salt.
Pink salt.
Pink Himalayan sea salt, right? Iodized salts, they're mined, they're taken from the sea. So to me, when you're working with salt as an ingredient in a dough, it doesn't make a difference what the salt is. If you're using it as a finishing application, I always go with a premium salt, a flaked salt, something that has a good clean kind of finish. But when we're bread baking, it doesn't make that much of a difference. So when we're looking at salt, it just should serve a couple of functions. It should enhance flavor. That is something that I'll prove to you on the 3rd lesson. So you're going to have to recall that information a little bit, and hopefully by the 3rd lesson we all tie it back together. Regulates enzyme activity. You should be able to see that here if this thing starts to go real quick. And then the tightening effect on the gluten-forming proteins. That is something that we're going to showcase in our lesson 2 when we start to mix the doughs, and we're going to do one as a control factor without salt. So you can sort of see how the dough performs under those conditions. Yeah? You should. We're going to move to the next one real quick. Yeah. Since we have some time, we've got plenty of time. Yeast. This is where it gets maybe a little bit crazier. And there's life. I think it's going to happen. I think it's going to happen. It's going to be really tight though. But I figure, hey, 3 minutes late, it's okay. We're here to learn, right? Sorry, yeast. Do you know that there's different kinds of yeasts out there? Give me an example of what we got. Instant.
Fresh.
Fresh.
Active.
Dry active is the other one. And then there's this osmotolerant category that really doesn't play into what we're going to be doing. So we're going to really be looking at the instant yeast component. And instant yeast is from the same cell structure as you would get fresh yeast that's just been dehydrated in the process and becomes shelf stable. Yeah. So what you're trying to do with yeast is you're trying to feed it the simple sugars that are present in the starches in your flour, and that will kickstart fermentation. Yeah. No flour, there should be no fermentation going on because there's no simple sugars for it to consume, so there's no food or energy for it to sort of release. Yeah. Bread fermentation occurs when enzymes break down the complex carbohydrate and turns them into energy, carbon dioxide, alcohol, and organic acids. The organic acids, that lactic experience, we're going to go into more flavor analysis in our second class where you get to sort of taste what lactic flavor profiles and acetic flavor profiles sort of taste like. We'll do a little blind taste testing. Does anyone mind if I blindfold you for like a couple minutes real quick? It sort of would be fun. If you feel comfortable, could you actually bring in a blindfold so that I don't have to bring in a bandana of mine? That would be sort of disgusting. So if you have something, and I'll send out an email reminder if my brain actually works with those components. And then the varieties that we sort of talked about is the fresh yeast, the active dry, and the instant yeast. Be careful, they're not all interchangeable. You can't just take one over the other. I'm going to give you 3 conversion components that you can use later on in life if you're ever sort of going to use this again, which is hopefully the goal. So what we're going to do is fresh to instant yeast. You take the weight of the fresh yeast and you multiply times 0.4. You go fresh to dry active, you multiply times 0.5. If you're going backwards from instant yeast to fresh yeast, I multiply times 2.5.
Times 2.5?
2.5. And if I go dry active to fresh, I multiply times 0.5. Yes? Fresh to instant is, 0.4. Dry active is 0.5. Fresh to dry active. Yeah. Going backwards, instant to fresh is 2.5, and dry active to fresh is 0.5. All right. So, yeah. So these things are sluggish, huh? So I'm going to ask you to do something because it's a little sluggish, but I need to close this lesson just with this component. If you do me a favor and just sort of squeeze the balloons, and there should be starting to feel a little pressure on some of them. Which one do you think has the most pressure right now? That one over here. So let's just quickly look at what you have here is flour, and this will expedite. I'll leave it out so we can see it in about 15 minutes. It's going to be pretty dramatic because it's going to travel up the entire bottle and blow the balloon off the top. So why is this one faster than the one with the salt?
Because salt helps to control fermentation.
That's it right there. So understand that very carefully. Salt will control fermentation because it will slow it down. Let's do this thing here real quick. And then let's see here. This is just water and yeast, and there's really not much going on there, right? That's just water and yeast. I bet with you by in half an hour when we test this, there's not going to be anything left. There's not going to be any more gas buildup on that. Any idea why? What do you think? No gas buildup on water and yeast.
There's no food for the yeast.
Bingo, that's it right there. Yeah, so if you understand that, that's a great little thing. So we've got number 2. And then we've got over here, flour, water, yeast, and salt. This one is going to be slightly slower in regards to fermentation cycle. Any idea why? I'm going to ask you real quick on that question. And what does salt do to it? That's it right there. Okay, perfect. You are like rocking this thing, guys. This is great. 6. And then the last one right here, and I think what we should, I was just getting all excited. Look at that, it's happening here. And this one is exactly the same as this, but it's moving slower. Any idea why?
Because the water was cold.
Cold water. So ideal fermentation happens at 75 to 78 degrees. That's sort of our magic window.
What was that?
75 to 78 degrees. That's the goal of the baker. Get your dough to 75, 78 degrees, and in our next lesson we'll sort of go over that. Do you guys have any questions in regards to the reaction of the ingredients in regards to these samples? And what I'd like you maybe to do at the end of the night, maybe before you leave, just look at them one more time, cross-reference to your notes, and see if you can draw the conclusion that I'm hoping that you're going to be able to see by the balloons that are doing their little magic expansion rates.
What was the cold water at?
The cold water was 55 degrees.
Okay.
And the other one was all room temperature, and room temperature
Is
is
about 60.
about 65, 68 degrees,
Okay.
69. So the difference of those 10 degrees is going to just slow it down even more. So this will always be the fastest moving one because it doesn't have that salt to slow it down. Is
Makes
good?
perfect sense.
So would there be a time that you want to use cold water? Probably not.
Maybe. We're going to find that out next lesson. Maybe. Yeah? Any other questions, concerns, issues, problems, complaints?
Thank you.
All right, well, no, thank you.